Hi everyone, and I hope that you're ready for a very exciting lesson. So without further ado, let's go ahead and take a look at our focus. Our focus is to use tables, equations, and graphs to solve problems. And by the end of this lesson, you should be able to answer this question: how could you explain to somebody else how to graph a linear equation? Here are some vocabulary terms that we're going to need to know in order to move forward in this lesson. Our first vocabulary term is solution, which is any ordered pair that makes an equation true. And a linear equation, which is an equation of all its solutions that lie on a line. So let's go ahead and take a look at an example. In this example of making tables and writing equations, we are having this problem. Suppose you save $3 each week. Make a table and write an equation to represent your total savings after a given number of weeks. So here's the table that we are creating. Our first section is the number of weeks, the total number of dollars saved, and the expression that we're using to represent that information. So we're letting W represent the weeks, that's the variable that we're using, and T is representing the total number of savings. So look at the pattern on the table. Your total number of savings for each week, it grows by 3 each time. And the equation that we would use is T, the total number of dollars saved, is equal to 3 times the number of weeks that have passed. We're going to do an example together. We see you buy CDs from a music store. Each CD costs $15. Make a table and write an equation to represent the total cost of buying a given number of CDs. So this is, we're letting C represent the number of CDs, and our expression is C times 15 because it costs $15 per CD. And T is going to equal the total number of dollars that were being spent. So if we put in 0 for C in our expression, 15 would be multiplied by 0 to equal 0, which is no money. Our expression here would be 15 times 1. Our expression here would be 15 times 2, because we're buying 2 CDs at $15 each. And then again, $15 for 3 CDs. We're going to use multiplication to figure out the total cost. So if we buy 1 CD that costs $15, the total is going to be $15. If we buy 2 CDs that cost $15, 15 times 2 equals 30. And then here we have 15 times 3, because we're buying 3 CDs at $15 each, would equal $45. If you see the pattern, it's increasing by $15 for each CD that you buy. We're also asked to write an equation to represent the total cost of buying a given number of CDs. So our equation would be 15 times C, whatever number of CDs that we buy is going to equal our total of T. Now what we're going to do is focus on graphing linear equations. In this problem, it states, Jared keeps track of how much dry food is in his cat's feeder. We're going to graph a linear equation that's shown, where Y represents the cups of food left, and X represents the number of days since he filled the 12-cup feeder. So our first step is to make a table, where we said that X represents the number of days, and we have our equation, our linear equation, where we have -1/2 times X plus 12. And we are going to replace our variable X that's in this column into our equation. So we can see here that X has been replaced with 0. So X coordinate is equal to 0 and Y is equal to 12. So I'm going to write that over here. 0, 12. Those are those coordinates. Once we replace X with 4 into this equation, our X coordinate is 4 and our Y coordinate is 10. and so on and so forth. And from there, we're going to graph the ordered pairs and draw a line through the points. Here we have our origin of 12 because no days have passed, so there are still 12 cups of food. After 4 days have passed, there are 10 cups of food. They're skip counting, so this would be 10 right here. And this would be 6, and this would be 2. 2, 4, 6, 8, 10, 12. And so on and so forth. So each point, x, y, which is what we graphed here, on the graph represents a solution to the equation. For example, the point 410 means that after 4 days, 10 cups are left. We're going to do an example problem just like this together. In this problem, we're asked to graph the linear equation y is equal to 5x plus 50, where y represents the temperature in Fahrenheit of a chemical solution after x amount of minutes. So we're provided our x coordinate. We have to plug in our x value into our equation. So we would have y is equal to 5 times 0 plus 50. Now 5 times 0 equals 0, plus 50 would equal 50. Then we're going to do the same over here. Y is equal to 5 times 2 plus 50. 2 times 5 is 10. 10 plus 50 equals 60. Same thing. Y is equal to 5, and we're replacing our x value with 4 plus 50. 5 times 4 equals 20, plus 50 equals 70. And then our last point that we need to figure out the y coordinate, we have 5 times 6 plus 50. 5 times 6 is equal to 30 plus 50 equals 80. Now we need to graph our points. We're graphing our linear equation. So we have x is equal to 0 and our y coordinate is 50. So we're going to go ahead and plot that first point. Then we have 2 and our y coordinate of 60. Our x coordinate of 4 and our y coordinate of 70. And last but not least, our x coordinate of 6 minutes and our y coordinate of 80 degrees. And then from there we connect our dots to represent our linear equation. There we go. So now it's time to review and bring back up our question that we brought up at the beginning of our lesson. How would you explain to somebody else how to graph a linear equation? I want you to think about that. You should be able to answer it. If you have any questions on this lesson, please don't hesitate to BBIM me or email me, whatever you need to do to get a hold of me. And don't forget to answer the questions below. See you guys.